Hi, this is Darrell Barnes with BarnesBasics, and we're going to spend some time working some ionic reactions and predicting precipitants in those reactions. And the first problem that I want to look at is calcium bromide mixed with ammonium sulfate. And what I want to do first is predict the products of this ionic reaction. Sometimes ionic reactions are called exchange reactions, and the positive ion matches with the negative ion. So in this case, on the other side of the equation, we would see calcium sulfate and we would see ammonium bromide. The next thing that I want to do is I want to write the elements, the individual formulas, and I'll do that using common oxidation numbers. I want to balance the equation, and then after that determine the solubility of each one of these compounds and thus predict the net ionic equation. When I look at an oxidation number sheet, by the way, I do want you to download the oxidation number sheet that I requested in the very first video in this playlist. Also a solubility rules chart as well. If you do that, we can have a good basis to run with this play series on ionic reactions and precipitants. When I look at the formula of calcium bromide, I would find out that calcium is +2 and bromine is -1. I know from a common oxidation number chart that ammonium is NH4 +1 and sulfate is SO4 -2. These two mixed together yield calcium +2 and sulfate -2 added to ammonium NH4 +1 and Br -1. Those are the reactants and those are the products. And Miss Sharman, Hughes, the one that's advising me on some of my content, says that a lot of the new textbooks have 2+ and 1- instead of +2 or -1. The first thing that we want to do is we want to balance each individual formula before we balance the equation. And so in this case, if we have bromide, we have to have 2 of these to make -2 to balance with the +2 calcium. It will take 2 ammoniums at +1 to make +2 to balance with the sulfate, which is -2. It will not take any action on calcium sulfate. This formula is already balanced. And then the ammonium bromide also will not take any action. So very nice. Let's take a look at this. We've got 1 calcium, 1 calcium. We've got 2 bromines, and we've got 1 bromine. So why don't we go for the easy fix right here and put a 2 there. Remember, we only use coefficients after we get each individual formula balanced. We don't mess with the subscripts anymore. So we have 2 ammoniums, 2 ammoniums, 2 bromines, 2 bromines, calcium, calcium, sulfate, sulfate. We're good to go. Everything is balanced. Perfect. The next step that I want to do is that I want to look and see which ones of these are soluble or insoluble in water. And when we look at calcium bromide, rule number 3 says all chlorides, bromides, and iodines are soluble. Iodides are soluble except silver, lead, and mercury. And since that's not silver, lead, or mercury, we will say it's soluble. And we will say that it's soluble according to rule 3. The next one is ammonium sulfate. Rule 8 says that all salts of sodium, potassium, and ammonium ions are soluble. And so this is soluble by rule 8. Next, we have calcium sulfate. When we go to the sulfate rule, it says all sulfates are soluble except those of barium, lead and calcium and strontium. So this is insoluble. This is insoluble according to Rule 4. By the way, if we look back at this problem, this has a sulfate in it as well, and it's soluble according to Rule 4. Remember that Rule 4 says that all sulfates are soluble except barium, lead, calcium, and strontium, and that's not any one of those, so we can mark that as soluble. Remember again that those that have ammonium are soluble, and so that's Rule 8. Rule 8. And this is a bromide, and all of these are soluble except for silver, lead, and mercury. So actually this is also soluble by Rule 3. Now, since this is insoluble, this will go into the net ionic equation as the precipitant. So we're going to say CaSO4 is a solid precipitant. And the idea is that when we mix relatively tame looking water solutions that are impregnated with these, we can actually get a precipitant. Probably this is white, I don't know for sure, but I'm guessing that it probably is. Seems like a lot of the precipitants in chemistry are white. Now, to work the ionic equation, we're just going to drop down all of these ions and with the amounts of those. So in this case, calcium is +2. Calcium is +2. We have 2 bromines at -1. We have 2 ammoniums at +1. We have 1 sulfate -2. We have this as a precipitant, so we're going to just leave this just like it is. We have 2 ammoniums and 2 bromines. Now, the other thing that I want you to pay attention to is that all of these individual ions are aqueous, and we should designate them as such. Let's put AQ beside all of these. I know this is a little bit of an afterthought, but it's the right thing to do. AQ. AQ. We can make a lot of our teachers happy if we do that. That way it will work out as it ought to. So in this net ionic equation, we will add in the ions that contribute to this precipitation. In this case, we have calcium in an aqueous solution, and we have sulfate in an aqueous solution, and those are the 2 contributors to this ionic reaction net ionic equation. The ones that are not participating can be crossed out, and these are called spectators. Spectator ions. Very good. I think we did a decent job with this. Calcium, 2 bromines, 2 ammonium sulfate, calcium sulfate, 2 ammoniums, 2 bromines. I think we did good. I think we're happy with this. Nice.